Right, hello and welcome everyone to Chapter 4, Section 3. So we are working through more material with linear type equations. So we're working with lines, but we're focusing on specific forms of writing. And if you look today, we see we are on point-slope form. So we passed slope-intercept, we worked on that. Today we're going to focus on that new one we're talking about, point-slope form. So this gives away what is going to be important, a point and a slope. So we will use both of those things. We'll write some equations and that'll give us some info. So this is the key today, point-slope form. So we will be given a point, some x, y value, and we'll also be given the slope. And we'll try to write our equation in the form that we'll see here. Point-slope form is y minus y1 equal to m times the quantity x minus x1. And we should have this down in our notes. But these two pieces here, the y1 and the x1, these come from a point that you're given. So you're given a point that has an x and a y value. Those go for the ones in your equation, and the x and the y that don't have the ones, those just stay as variables when you write your final equation. Okay, so we'll see that in some problems. So here's that equation again. So given a point, you'll plug that point in, and then the other thing you need to know to write your equation the right way is your slope. So everything in color here is what you need. 1 point, x and y, and your slope m. So all those things will be used to write your equation. And again, remember we're talking about lines. So straight lines are what we are using. So first example. We see we want to write in this new form we're talking about. That is point-slope form. And we know what that is. We wrote that down. We are given here this point, 2, 0. And it has a slope of -3/2. So there's my m, my slope, and here I have a point, an x, and a y value. So how do we write this? Where do we go from here? We'll always start with your blank equation, okay? So we have our blank equation. We know now the things we want to sub in are the things that we see in color here. So we're given m to be a -3/2. We can plug that in. And we're also given an x and a y value. So where there's an x1, I can put a -2. And where there is a y1, I can put a 0. So I can use those three things, plug them in, and then write my equation. So notice y1 became a 0, pulled from here. M became a -3/2, taken here, and x1 became a -2. So substitute those three things in. Now you'll simplify if you can, so that just means you want to make sure you write your operations the way they should be. So we want to leave the numbers. Subtracting by 0 doesn't change anything, so we can just get rid of that. And then subtracting by -2 is the same thing as adding 2. So we'll change that minus the negative to a plus 2. And then we leave it in this form, okay? We don't distribute the 3/2 because we want to be able to see the slope and that point that we use. That's the point. That's why we write in point-slope form. So leave it in that form. And that is the end of this first example. Okay. So we can also graph that thing if we wanted to. So you would plot the point that you were given and then do what the slope tells you to do. So we practiced this before. So the point you're given, -2, 0, plot that right here. -2, stay there. Now your slope is -3/2. So what does that tell me to do? My change in y over change in x. Change in y is up and down. Change in x is left and right. So my change going up and down is -3. So I should go down 3 and over 2. So from here, I go down 1, 2, 3, over 1, 2, get my second point that I used to find the slope, and then I can draw a line between these. So a graph of this equation would have this slope. So please draw yourself a quick image of that. You have a negative slope going through the point -2 and 0. Again, you find that using your point given and the slope. So we have that down. Now here's 1b. So we're given a graph. They ask us to write in point slope form the equation of the line that goes through this point given here and has a slope of -2. So this line, they tell us, has a slope of -2. That is our m value. And it goes through this point here. And this point for -3 has an x and a y. So how do we do this? Well, we always start with our blank equation. That is step 1. Write the equation that you're using. So we should have this in our notes, and the more we write it, the more it will make sense to us. So y minus y1 is going to be, we can substitute these things in that we know. So y1 will be the y value for the point given right here. x1 is going to be the point given here in this point. And m is given right here as a -2. So we know all these things that I circled here, we can replace. So with a simple replacement, we should get y minus a -3 equal to -2 times the quantity, leave the x right here, minus what is x1? It's going to be 4. Okay. Now we want to leave it in this form, but we will simplify any double negatives that we have. So let's change the y minus a -3 to simply y plus 3. Okay. And then everything else will just stay the same, because we want to be able to see the slope and the point given here. So we know our slope's a -2, and that point was a -3 and a +4. So we'll leave that there, and this should be our answer. So let's check and see if any of these match up. Well, D is out, C is out, and A is out. So does B match up? Y plus 3, okay, equals -2 times the quantity, x minus 4. So B looks great. That is our solution for 1b. So what we need to have is a couple steps and this equation here. So have that piece as we move on. Let's double check and be confirmed. Now we talked about these steps yesterday, so we know that when we're asked to write an equation, when we're given a slope and a point, we can just plug all those things in and solve for it. But when we're given 2 points, we have to first find the slope, and then we can do everything else that we talked about. So this we have in our notes from last section. We'll review that again, and we'll work through those steps as we see that coming. Now the second type of example asks us to write in standard form. And we have this in notes from last chapter, but we remember standard form. We had those capital letters next to our variables, and we had our x's and our y's on the same side, and they were equal to a number. So this is our standard form, where A, B, and C are all just numbers, okay? They're whole numbers. So that's our standard form, x and y on the same side with some whole numbers next to them equaling some constant. So in other words, we need to get rid of any fractions that we see, and then make sure our x's and our y's are on the same side of our equation, okay? So in standard form, we know we want everything, our variables, all together. So we have our original equation. Now, what do we need to do? Well, we don't want any fractions. So how can we get rid of this fraction? Well, the easiest thing to do is to multiply by whatever the denominator is. That'll cancel it out and you'll be left with the whole number, whatever's on top. So we have to change everything. If we want to change one thing, we have to change everything. So multiply everything by that 4. We get 4y on the left. On the right, these 4's will cancel out. We'll get just 3x here. And then 4 times a negative 5 gives us a negative 20. So we get all of these here. Now we know for standard form we need x and y on the same side. So we need to shuffle some things around here. So we could subtract 3x from both sides. That would give us negative 3x plus 4y equal to a negative 20. Are we done? Well, no, we're not. Because we don't want a to be negative. So whatever number is attached to x, we call that a in our equation. And a has to be positive, okay? It must be greater than or equal to 0. So a has to be positive. How do we make this positive? Multiply everything by a negative 1, which essentially just changes the signs of everything. So change all the signs. We get a positive here, a negative, and a positive. So this now would be our standard form. X's and Y's together on the same side. X is positive, and we are good to go for this example. So standard form ones are just a few steps. The hardest piece is just remembering what that means. From then on, it's just shuffling a couple things around, and you will be great on those types of examples. So here's another one with standard form. So we remember standard form tells us to bring x's and y's together on the same side, and we want it to equal some number, okay? So here's our original. Let's write that. It's going to be equal to this quantity on the right. All right. So I know I want to get my x's and my y's together, but I need to distribute this too. So let's do that. So here we'll get 2x plus 8 when we distribute. And over here we still have the same thing, y take away 3. Now I know I want my x's and y's together. So here I can subtract 2x from both sides. So 2x here and here. So with a little simplification, we can get closer. So here this will be an 8. This goes away. On the left we get minus 2x plus y take away 3 is equal to that 8, okay? Now, we can get rid of that negative 3 because we don't want any constants on the left side. We just want our variables. So we can add 3 here and here. And with a little bit of addition, these will cancel out. On the right, we will get 11. So negative 2x plus y equals 11. Now this is something you want to pay attention to because this is a trap solution, okay? You will see times where you will have something that looks like this and you'll look at your answer choices and you'll say, I'm looking at B and I see that this is an option. I'm going to stop and circle that because I think it must be right since that's what I have here. Well, the answer is like, yes, you have done appropriate steps, but the problem is we're not finished, okay? Because our A value, the number attached to X, needs to be positive, not negative. So B and A can't be correct. So we need to change all of these signs here, multiply all of these by a negative 1. So when we do that, our final solution will actually be a positive 2x, a negative y, equal to a negative 11. So which answer choice option is that? Looks like C to me. 2x minus y equals a negative 11. So we have our x's and our y's on the same side, and our x's are positive. So all that checks out for 2b. And there we confirm. So have that piece down as we look at a third type of example. So we can also have problems that will make sure you're on your toes and you still remember what slope-intercept form means. So I told you this wasn't going away, so hopefully you're starting to believe me. So y equals mx plus b is our slope-intercept form. So we want to make sure this thing, all of this, is written in this form now. So we need y alone, some number times x plus a constant. That's what we need. So first step, take what you're given. Now from here we want to make sure we distribute that 4/3 to both things. So 4/3 times x is just this term. 4/3 though times a -3 becomes a -4. 3's cancel out, you're left with the numerator, keep the negative. Now from here we want to get y alone. So to get rid of the -5, we have to add 5 to both sides. So y becomes, if we back up, on the left, these will cancel out, so we'll get just y. On the right, this term stays the same, but here, 5 take away 4 becomes what? A positive 1. So we'll get y equals 4/3 x plus 1. So we're at this step now. Now we have to ask ourselves, is this written in the form y equals mx plus b? And the answer is yes, it is. We have y alone. Here's our m, our slope, x plus some number. So that's perfect. That's the form we wanted in. When you're looking at slope-intercept form, you should be able to see what the slope is and what the intercept is. So if I wanted to pull those out of this equation, I can identify the slope as 4/3. I can identify the intercept as positive 1. So this is in fact in that form. So please have this piece down for this first example 3 type problem. Now here we see one more that asks us to put it in slope-intercept form. So we know we want to isolate our y because slope-intercept tells me I want y equals mx plus b. So notice y is by itself here, okay? So since y is by itself, that's what we want to try to get in this equation. So first, let me write what I'm given. So here's what I'm given. I can subtract 3x from both sides because I don't need that term. I want only the y eventually. So subtract that 3x, and you must do it from both sides. So these will go away. That becomes a 0. On the left, we'll get 2y. On the right, we now have -3x plus 6. Now this is almost ready, except we don't want 2 y's. We want only 1 y. So as we're thinking, what can we do here to get y by itself if it's tied by multiplication to that 2? The opposite of multiplication is division. So divide everything by 2. These will go away. We'll get left with only our y, which is exactly what we want. And on the right, we'll get an expression. So -3 divided by 2 is just that fraction. And we still have our x. Plus 6 divided by 2. Half of 6 is, easy number, comes out to 3. So this is now in our right form. Y is alone. Our slope here is a -3/2. Our y-intercept is 3. So the whole point of slope-intercept form is that we can now identify the slope. This is my m. And our y-intercept, that's b. So given the slope-intercept form, you can check to see, can you identify those things? So there it is. And now looking at potential answer choices, I see A has to be correct. The rest of these are off. And we will double check that. But make sure you have the steps and the right form, slope-intercept, for 3b. And we see confirming A is correct. So please have that for this one. Now, one fourth type of example to consider. You'll have a couple like this that are using realistic geometry patterns with these equations that we talked about. So this is a real application for these concepts, okay? You're looking at geometry, surface area, real two-dimensional or three-dimensional shapes. So here's something to think about. In this case, we have a trapezoid. We have 4 lines. But we're only going to focus on one of those lines. So the question asks us to write an equation. Now here's where your reading skills come into play. You need to understand which form they're talking about. So they say point slope, so we identify that piece. And we know it's supposed to contain the side BC. So the side BC is given here. So we'll need to find out what is the slope and the y-intercept of this line. And we need to find a way to write this particular form given this line going on the right. So in this case, it'll be point slope. You don't have to draw this picture, but we will write the points down, okay? So be ready for that as we move to the next slide. So we're going to jot down this point and this point on the next slide. So that is the information we will focus on. So first we'll find that slope. So here are those 2 points that we said we wanted to focus on. This piece I want you to have down. These 2 points for our line. So given, and this is something we talked about yesterday, given 2 points, you can write the equation for your line. Because you can find the slope, and after that, the rest is just plugging in. So given these 2, we can plug in here. So we said this one was our x2, y2. So we would do y2 minus y1, which is -2, take away 3. Difference is here. And our x's would be 6 minus 4, taken here. So we simplify all that. We get a -5 on top, +2 on the bottom. So our slope, we know, is a -5/2. So have a slope of -5/2 for this example, please. Now, once you have the slope, we can plug in either point. That will give us an x and a y. These will be the x1, y1 in our point slope form. So we know we're generating our equation from the blank point slope form. Y minus y1 equals m times the quantity, x minus x1. Good. So the things we'll plug in here that we'll need to find to make this equation written the right way, we need to plug in x1, y1, and the slope. The regular x's and y's don't go anywhere. So we already know our m. We said that was -5/2. But the other thing we're going to need is an x1, y1. So notice we actually have 2 of those. We have an x1, y1 here and here. So we can actually use either one we want to write an equation. So it's up to you. You can choose either point. So if you use this point, notice you'll have a -4 here and a -3 here. If you use the second point, you'll have a -6 here and a +2 on the left. So you can copy down either one of these. No need to do both. But just know that you can plug in one point and have your equation for that. And also, it is very important to remember that you can plug in either point, okay? Either point will work. So it's up to you. It is your choice. So the answer is either the equation we have on the left, given the first point, or this equation given the second point. Either one works fine. So our solution, we need to have down either the first equation or the second one. depending on which point that you wrote down that you tracked. So this one tracks here, and our first point tracks here. It's okay for them to be different because different points give different equations for this form. Now they'll also ask you occasionally to write in standard form. So we already have the equation down, either one of these. Now they ask us to write it in standard form for that line. So we can take either of these equations that we had here. So we could use either one, we'll arrive at the same solution. So say we use the first one. We'll rewrite that to begin this part B problem. We want to write this equation in standard form. So start with our original. Now we know we need to have x's and y's on the same side, right? So first distribute. We get a fraction here, and we'll get a positive 10 when we multiply these two. Add 3 to both sides because we want y alone. And now we need to make sure we get our x's on the same side as our y's. But we want to get rid of the fraction. So how do we get rid of this denominator? You multiply everything by 2. So notice here, all the fractions are gone. And now we can get the x's on the left by adding 5x to both sides. This term will go away. We'll get a positive 5x over here. That's what we get with this step. So let's check this. Is this in standard form? Are my x's and y's on the left? Yes. Is the x positive? Yes. So this checks out for standard form. That is exactly what that looks like. It looks perfect. So our answer for 4B, the standard form version of that equation, has to be exactly 5x plus 2y, and it equals 26. So please have that down as we jump into some problems and some practice for this section.